Hello, this is Ruby. Today we're going to talk about continuing Chapter 7, Sampling Distribution of the Means, and today we're going to talk about a mean that's between mean and z. So we're using the same set of parameters that we've used in our other two problems. We still have that the average weight gain for students in their freshman year at Los Angeles Valley College is mu equals 9 with a standard deviation of 6. So essentially it's 9 pounds with a standard deviation of 6 in the population. We know that the distribution of scores is approximately normal, which is important, otherwise we can't use the z-score, and a sample of n equals 4 scores is selected, and the average weight change is computed for the sample. So what we're looking for is what is the probability that the sample mean will be a weight gain between 9 and 12 pounds. So what is given from the problem is we have a population mean of 9, standard deviation of 6, a sample size of 4, a sample mean of 9, and a sample mean of 12. So the first step, as always, is to compute the standard error. When we compute the standard error, what we do is we take the standard deviation divided by the square root of the sample size. So in this case, we have 6 divided by the square root of 4, because 4 is the sample size. So we take the square root of 4, which gives us 2. So we have 6 divided by 2, which is 3. So our standard error, just as before, is still equal to 3. Now this one's a little bit different in terms of the area, but the distribution in terms of writing it out is exactly the same. So we still have 0, 1, 2, 3, -1, -2, and -3 to show us that we are going to be using the z-score distribution to find our answer. Then we go ahead and make our corresponding marks. So we have a mu equals 9, and then using our standard error, which is 3, we know that a z of 1 corresponds to 12, a z of 2 to 15, a z of 3 to 18, -1 is 6, -2 is 3, and -3 is 0. All right, so the area that we want is a mean of 9 and a mean of 12. So curiously, for the mean of 9, what we know is it's right on the mean. So the area that's going to be between z and mean of 9 is going to be 0 because it's right on the mean. So the other area that we want is the area that's between a mean of 0, our population mean of 0, and our mean of 12. And so that one, we're actually going to go ahead and have an area. But just for consistency's sake, I went ahead and I did z for both. So we look at z for the 9 pounds, and we do it exactly the same way as we've done it before, where we take the sample mean, we minus the population mean, and we divide by the standard error. So we have 9 minus 9 over 3, which is 0 divided by 3, which is 0, because we're right at the mean. And then we take the z for 12 pounds, which equals 12 minus 9, which is 3. So we have 3 divided by 3, which equals 1. And so that's going to be between mean and z. So then we're going to look at in our z table for these proportions. And remember, again, we're looking at the proportion that is between mean and z. So the first thing that we see is that 0, when we look at 0, between mean and z is going to equal 0 because you're right at the mean. And when we look at 1, we know that the mean between mean and z for 1 is going to be 0.3413. So our answer then is that when we're looking at to see this proportion of people that gain between 9 and 12 pounds, it's 0.3413. So it's about a third of students as the probability that they will gain between 9 and 12 pounds in their freshman year. And as we talked about before, sometimes people like to report this as a percentage. So to get 34.13%, you would just take 0.3413 and multiply it by 100. Now, so if we were to look here and we were to look at our situation in terms of what we're going to be looking for is a 1 here. What we see is that our proportion that's between mean and z is 0.3413. So that's where that proportion came. For a z of 0, what we have is proportion between mean and z is equal to 0. All right, thank you. Have a good day. Bye-bye.